My name is Michael Solati, and I am joined on stage by
Robert Crowdis. It's a pleasure to be here. I'm really excited to open up DevFest today to speak on modern web applications.
Well, pausing on that, just so you guys know, this is the real keynote, okay? Everything you heard before, this is going to blow you out of the water.
This is it. This is the truth.
So Rob, do you want to go first?
Yeah, absolutely. I'd love to. Thank you. So this presentation is going to cover the definition of web applications, because you'll find they have some differences from websites. You're going to see the history of their development and their growth, and you're also going to find some coding at the end of this just to kind of cover and see exactly what a web application is. So we hope after this presentation you'll have a greater understanding of this and where perhaps the future of the internet and web applications and web pages will start to look like.
And I just want to add, this is going to be really important because as we continue throughout the day, we have other really talented speakers in web coming to speak here. We're hoping this is going to lay the foundation for everything else you guys see today in this room. So, un momento, por favor.
Ready? Yes. Almost. There is, I just wanted to point out real quick, there is, down where the keynote was, there is actually another speech as well. Just was told to point that out as well. I see that we have a fantastic amount of people here, a great audience. But just thought I'd throw that out there. So, moving on. We need to define what a web application is and what a web page is, and get a good understanding of those before we start jumping into what we want to talk about. So let's define what a web page is. I would say a website is defined by its content. What do I mean by this? Because a web app and a web page both have content. Well, if you look at something like a blog, everyone visiting has access to the exact same material. If I go to a blog about cooking and recipes, I can just see everything that Michael would see. It's shared content. The only thing that has user input there would be perhaps searching for a topic or something that I really want to make that day. Another good example of a website would be the Southern Connecticut or any university's website. It offers any visitor or user information on things such as like cancellations, school events, and even what classes are open. There is some user input there which we'll cover, but overall it's an information portal, which is really what I would say the definition of a website is compared to a web application. Like I said before, the same data is available for everyone. I think that's really the great big takeaway from what a website is. Now, how would I define a web application? The difference here is they're defined by user interactions. Now, I could even go as far and say it's a little more about customization, which you will see in just a short moment. An example of this would be Facebook. Facebook is a web page. However, you can really think of it more as a web application because you have a user profile. You are messaging friends and other people and seeing things that you like. It's a tailored experience to you, the user. And another great example would be something like a continuation of the Southern Connecticut website. I'm sure some of you that are students here understand BannerWeb is our service. It lets you register for classes, see your grades, and in addition, drop grades if you really need to.
By the way, I think last day to drop was yesterday, so yeah, you're committed the rest of the semester.
Either way, takeaway from a web application is that it's tailored to a user's experience. It's supposed to be unique for them. Any data that is sent in is usually processed by a system, stored, and can be kept and used for later use. Obviously here, I have a diagram to paint the differences between the two. I would just like to restate, web apps are defined by interaction, websites are defined by content. That is very important when you see, you can ask questions to yourself, like I gave the Facebook example, but what would you say eBay is? Is that a web app or is that a web page? Now, you may notice something as well. The middle location there, the core of both of them are essentially the same foundation of HTML, CSS, and JavaScript. So I guess this could raise a question. If they share so many similarities, can a website be a web app, and can a web app be a website? I guess we should keep in mind as well that they're not exclusive categories. They can have many elements of each other. So, and a great example of this is Wikipedia. Wikipedia is a website. However, you can edit articles and you can view articles, and seeing an article yesterday may not be the same one you saw today. Because there is web interaction there and logs of all of that. It is a tailored experience, but it is also shared as well. I would say one other fantastic example is weather.com. Besides the .com being in the name, I find this to be on many smartphones today. If you just give a quick swipe to the left or right, you can find the weather for, forecast for today, in the future. Pretty much you can subscribe to anything with your profile. I would say this, in turn, makes it a web app. However, weather.com in itself is a web page, just with many web app elements making it up. So now that I've kind of defined a clear understanding of what a web app and a website is, we need to understand where they came from. Michael, would you like to take it from here?
So hopefully we're going to have a chance to go over kind of the history of websites to web applications. And like we said, there's going to be a lot of overlap between the two. But in order to do anything like that, we're going to have to go back. We're going to have to go back all the way to 1995, where our timeline starts. So here's our general timeline. We look at between the years of 1995 to 1997, and this can be the origination of what we'll call our dynamic websites. Between 98 to roughly 2007, we start the introduction of client-side applications, and from 2008-ish on, we get to the advent, or like the real influence of single-page applications on the web. So we're going to be starting off with covering the dynamic site era. So, like I said, dynamic sites started roughly in 1995, and the first thing of prevalence, and it's still prevalent today, is PHP. Prior to PHP, you would have websites that were just the plain HTML, that when you hit up a URL, the content was transferred over, and it was just the same content for every user. In this case, you're still receiving the same content for every user with PHP, but what ended up happening is something that we call SSR, server-side rendering, where code was automatically generating the pages that were going to be displayed to the user. Meaning, if you look at a website like Wikipedia, the template for almost every page is virtually the same. You have a body of content, you might have a general image, some links on the bottom as to related content. The template is virtually the same for every page. It's just the content that's being swapped in there. So all of a sudden, we can store all of this content in an SQL database and just swap out the content depending on the route a user visits. We don't need to pre-make pages for every single entry in Wikipedia, because whoever's doing that by hand, that is an absolute nightmare. Besides PHP, come 1997, we get iframes. And iframes are still used today in some capacity, while I may advise you not. I want you to think of something like YouTube. You go to youtube.com, you find a video that you want to be able to embed that video onto your website. There's a few ways to do it. They make an HTML snippet readily available to you, but the other option that YouTube provides is something called iframes, where basically they just embed a generated page into your website where they have the player already set up. So this kind of builds into this idea of being able to build dynamic websites, where inside of your main page, you can have a mini window where you can load in any other content, allowing you to swap content inside of that frame really, really easily. And this kind of builds into an idea we'll hit later with web components. I would say this is a precursor in behavior, not in execution.
Our priorities. Now, come 1997 to roughly 2007, we start the development of client-side applications. Client-side applications are typically what we use most often now, and this actually starts in roughly 1998 or 1999 with the Microsoft Outlook team. Now, simply put, when we mentioned before with PHP, what would happen is when a user visits a route or a URL, the browser goes to the server, it requests an asset, which is the HTML page, and it gets sent back. And a lot of places that still do this SSR-style loading, you might notice when you visit a route, there's a quick flash pop as the new page gets loaded in. So anytime you needed a resource or asset, you had to go out, fetch a completely new information, bring it in, and update the view. With XML HTTP, which again, as I mentioned, this was a project started by the Microsoft team, what they were looking to do for their Outlook application is instead of having to refetch the page, they would just have the JavaScript hit up the server, make a post request, grab the updates, and manipulate the DOM based on that new content. That way, you're not loading in new pages all the time, just updated information. Microsoft ended up shipping that with IE 5 in 1999, and then every browser thereafter mimed what they did. Our next advent in client-side applications is the actual definition of AJAX. Now, Microsoft was tinkering around with AJAX, and so was other groups like Mozilla. AJAX standing for Asynchronous JavaScript and XML. And the idea was we can asynchronously, meaning in real time, separate threads, request this information, load that content in, and swap it out. Oh, lovely, it's right there. But this is where the standard starts to get put into place. And a lot of people in a lot of browsers were implementing things differently, which is kind of painful if you're a developer having to account for every single browser. But there's one company that did that and did that really, really well, and that company is Google. In 2005, at the same time that the term AJAX was defined, Google releases Gmail and Google Maps, which were client-side applications. Again, once the application is loaded into the browser, the JavaScript is fetching all that new information and loading it in without you having to constantly refresh the page or pull up, make requests for a new web page to be rendered out for you. Like I mentioned, they had done that with Gmail, they had done that with Google Maps, and they were using standards that worked across browsers, making it a little bit easier for everyone to be able to access and use these websites, and they were doing it at scale. Mind you, I think some of you guys remember, Gmail used to be invite only. You could only invite 10 people at a time, and then by 2007, everyone could get it. But they had to start at some scale, and they were the first to do it right. Another thing of importance here is the advent of jQuery. Now, this happened in an event in 2006. I believe the very first version of jQuery was spit out within 24 hours. And the importance for jQuery is it made DOM manipulation, making AJAX requests, and all these other things dead easy. I'm willing to bet more people in this audience know how to use jQuery than pure JavaScript for DOM manipulation. Just by show of hands, how many of you guys have used jQuery before? Now, if I ask you guys to get the information of a form input with pure JavaScript, how many of you can do it? We cut that down in about half. Again, jQuery, massively prevalent for making this type of work easier. But that kind of covers the advent of client-side applications. Once we have got client-side applications up and they started to take a foothold, comes to our next step in the timeline, and that is our single-page applications. When I mentioned before with PHP and our server-side rendering, we were making fetches for new content and new pages to be rendered out. The client-side applications started to make this easier, but single-page applications prevented us from needing to make any request other than an initial payload from the server. After that, all the content, including new routes, were being handled by the JavaScript. Mind you, before we get into anything too big, there's one really important feature that came out during this time, and that's PhoneGap. PhoneGap was created, I believe, in 2008. Yes, 2008. And what this allowed developers to do is, hey, you know how to write HTML, you know JavaScript, you know CSS. We're going to take whatever web application that you built, and we're going to bundle it into an APK or IPA, so you can release it on the Android Play Store. It was Android Market back then, or the iOS App Store. Again, taking the technologies users already know and allowing them to build powerful applications that exist cross-platform without having to learn Java or Objective-C or anything like that. Now that PhoneGap has been created, we get into the advent of Angular.js. And this is, in my opinion, the first modern single-page application framework. While there had been others like it, nothing took over the market quite like Angular.js did. In fact, if many of you guys do your mobile banking with Chase, Wells Fargo, anything like that, chances are your website was built in Angular. In fact, when you guys go to register for classes come Tuesday, seniors come Tuesday, the login portal, that's an Angular.js website right there. And when we mentioned the PhoneGap Cordova being created just before Angular, as a heads up, all those mobile applications that you use for your banking were likely PhoneGap apps written with Angular. Next point of note is responsive web design. And you've probably heard this term used. If you guys are new to web development, you probably heard use Bootstrap. It makes everything easy. Use Bootstrap, it makes everything easy. And that allows for scaling. The idea is that we take an approach that we design for a mobile size first, and then we scale up. That way we can build applications that look good on any size screen. Because I'm sure you guys have been to some websites and you have to actually zoom into it in order to be actually able to read any of the content. Because it wasn't designed for mobile. Well, responsive web design, and this actually came as a benefit of CSS3, which allowed for media queries, which means we can get a measurement of the size of the screen, resize it as needed, becomes really powerful. And virtually every web application now uses responsive web design thanks to CSS3. A few other quick things. We have web components, which is created by Polymer. The idea is with HTML5, instead of using the native elements like divs, sections, p tags, you can create your own custom tags. And following that, we have React and Ionic. React is obviously very prevalent as it's one of Facebook's JavaScript frameworks. But Ionic, luckily, we'll have a speaker later on today, Mike Hartington. He's going to discuss more of that. It allowed Angular developers to develop web applications that looked and feel like iOS native apps or Android native apps. And then most recently, we hit up new web frameworks like Vue and Angular. And you might see Angular is listed twice. I promise you there's a difference. Angular.js, often referenced as Angular 1, has been one thing since 2011. Angular, which is Angular 2 or greater, complete rewrite of the framework. And when we start to build our application today, we're going to be using Angular in order to do that. So, OK. We're going to be trying to build a web application today. And hopefully, we can get that done in roughly 10 to 15 minutes. Now, I want to say this is going to be an initial shell. What you see today might look and feel more like a website for the time being. But we're going to do a few things that make it feel appy when it comes to design and making sure it looks like it belongs on a user's phone. And from there, we're going to make the code available to you guys. If you hit us up later, you can build off it from there. Rob, do you want to do some explanation on the app?
Sure. So the web app we're going to do for this presentation in particular is going to be small in scale, like Michael said, because we only have to work with what we have for resources. So our real constraint here will be time. We are going to attempt to show movie information from MovieDB, which is going to be our source of movies in this case. It's going to be a very simple app, like Michael said. You're going to be able to click to see movie information. You're going to be able to see the most recent movies. It's going to be presented in a user-friendly format, which is very important, of course. I always try to think of the user when you're developing something. But you also got to think about the extendability with programming. Since we're using Angular today to just kind of build this app very quick, you're going to see within 15 minutes, with just a few lines of code, we're going to create something that looks fantastic. You're going to be able to use it on any device you'd like because we're working with a single-page application. And in addition to that, it's extremely extendable. If you wanted to add any kind of thing like, oh, I want to see people who wrote comments to these reviews, we'll be able to do that. If you have any ideas, any extendability as well, like I said, feel free to hit us up afterwards.
Well, we're going to accept pull requests into that, so please feel free to add to the code.
Yes, absolutely. So this is actually going to be the end result after we're done with our few lines of code. You can see it's kind of nice looking for, this was a desktop view. But if you pulled this up in your phone, it would work just as fantastic and look just as clean. The scalability Angular offers is fantastic. I can't emphasize it enough.
So now let's get into building some code. Now we have the application up and running in a tab, and what you see, Rob, one more?
Yes,
so when you build an Angular application with the Angular CLI, the first thing you see is this. It's a welcome to Angular app. This is I actually coded this. No, it's auto-generated for you. You have to do nothing.
You don't do anything. You generate the Angular application, and it comes up with this screen. So this is what we're going to be seeing every time we generate an Angular application.
Now, for this project, we have a few dependencies. We have these dependencies pre-installed. So first thing we're going to do is we're going to be using a little bit of Sass, and immediately we're going to turn that one page into something that looks a lot prettier. So would you mind just uncommenting all this Sass? Save it, and let's flip back. All right, so all of a sudden we get the black, we get the white text. This is starting to look a little bit better. Mind you, this is still a very, very simple web application. We want to be able to build and do something a little bit more powerful. Rob, do you want to?
Absolutely. So right away we can see our changes immediately, which is pretty great in itself. So we're going to go ahead and start working on this. We're going to go to app module. We're going to import some stuff.
So the assets that Rob is importing in is we're going to be using a library called Angular Material, which provides pre-made web components. Again, Angular is a component-driven architecture, and most modern web frameworks are component-driven. This will allow us to easily and quickly build applications with elements that have been pre-designed and have predefined behaviors. So we don't have to build everything from scratch. So while Rob is adding that, just by a quick show of hands, how many people have Android devices in the audience? OK, a decent amount of you. So some of you guys have probably used either the Gmail application, Google Maps, or something like that. We're trying to mime the style that Google uses in their native applications for this. So with that, let's actually, now that we have imported some of those modules and assets, we're going to write some quick HTML so we can list what one element is going to look like so you guys know kind of the base of what our application is. So right from the top, you'll see the mat toolbar. And the toolbar is that bar up on top that says what application we're in. It's the movies. Following that, we have mat list. The MAT prefix, it's everything in that material library, mat, material. I think we're good there. But we're going to be listing out elements with a little bit of preview information. So let's go back to our Chrome. All the way back.
Yes. So again, we are using a static version. We predefine the value of it in this case and the image. So you can already see, quite literally, we have only put in CSS, and using the material library Angular offers, already our app is starting to look presentable. In how long this took, granted, using a snippet, that code still took very little time.
So this is awesome with the static content, but users don't want to see just the movie it. We need to be able to get relevant movie information for the user. So what we're going to be using, the first thing we're going to do is we're going to build a service. What services allow us to do, services are pretty much an entry point in our application for data. It's a middleman. So whenever we want to get information from the web, we go through a service. The service is going to store and hold that information. That way, the information we want to use in any different component, in any different route, it all exists in one singular place that we make requests. And the benefit of that is, let's say that the entry or the data source that we want to get everything from changes. Instead of having to go to every single page or every single component to update that information, we just have to update the service because all the components are requesting the information from the service. So Rob's going to write the command to generate a service, and this is fairly simple. ng generate service, and the service is going to be movies. And as soon as he hits enter, it waits.
It waits.
And it generated our service.
So we can hide that. You don't need to see that.
Yeah, clap for that. Guys, clap for that. There we go.
I didn't think I could do it. Thank you so much.
The service has been generated for us, but we're not quite able to use it yet. Angular follows a model called dependency injection. So Rob's going to have to go into the app module, and we're going to import our movie service as a provider. Providers provide data throughout our application. And there's one more thing we're going to have to import. So I'm going to let Rob catch up with the import.
Yes, I didn't import yet. Sorry about that.
Go ahead.
Yes.
So we're importing two things. We're importing our HTTP client that allows us to quickly and easily make HTTP requests, because we are not going to use jQuery for our AJAX calls. And once we get our HTTP client, we're going to be grabbing our movie service as well. And everything we're going to be putting in, it's inside of the decorator. You see the ng module. That is a decorator known in TypeScript and ES7, ECMAScript 2016, I believe. Too far. This is the entry point of our application, where we list some imports in our declarations, and that's where our movie service and our HTTP client is going to go.
I'm just typing the code instead of using some beautiful snippets.
Yep, there you go.
Very good.
So we just add them to our provider, the movie service as our provider, and we're going to add the HTTP client module into our imports.
Yes. Here we go. And the provider is the
Movie service, yeah.
There we go.
And as soon as we save that, now we have the ability to quickly and easily make our HTTP requests to the movie DB and grab that content. So let's go back to the Chrome and see what that looks like.
Yep, it's beautiful, right?
And we have done nothing with that information yet.
Yes.
We're not even requesting the information yet. We just laid the groundwork so we could request that information. So let's actually get that information. We're going to go into our movie service, and we're going to do a little bit of work. We're going to swap actually all this out with some pre-written code. Makes it a little easier for us. But just as a quick show, it's a fairly simple function. Our constructor, we inject our HTTP client. That way our service has access to it and can use it. And the very first thing when this class is initialized in our constructor, we're going to assign this._movies to our HTTP GET request. So we just do HTTP GET MovieDB API. We map the response, so we just modify the response that we're getting back. And then we assign it to this.movies, and right after the constructor, we have a get function. That way, in our view that we actually want to be able to render this content, we just get from this service, and we can render it out right away. So let's go into our app component, and we're going to import our movie service into there, the component class first.
Yes.
We'll eventually get there.
Yes, that was good. So yes, here, you go in. Sorry about that. We have to import, I'm sorry?
Import the movie service.
Yes, my apologies. Good old snippets. Knows exactly what I want from
Movie service.
Yes, sorry.
And there's one other app import we're going to bring. If you guys get the opportunity to become more experienced with Angular, you're going to appreciate this. We're going to import an observable from the RxJS library.
Actually, I believe.
No.
No?
No.
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 Believe that?
Import observable from RxJS.
Sorry. Sorry about that. You want to finish?
Single quotes.
Single quotes. Beautiful.
RxJS /observable.
No period. Would you like to fix it?
I'll fix it real quick.
Yeah. Sorry about that.
All right, so we're just going to be importing the observable for RxJS. And what observables allow us to do is easily grab content. Because we're making an AJAX request, we're doing the HTTP request asynchronously, we need to wait for that content. Observables pretty much keep us, it follows the observable model, which says anything that subscribes to this, when we get a new value, we're going to emit that value out to anything that's listening. So right here, we're going to create our constructor. In our constructor, we're going to inject our movie service. And right inside of here, we're going to create a get function so we can pass our movies to the template. So we injected our movie service into the constructor of our component. We created a get function that grabs the movies that we have in our movie service. And what we're going to do with this information, we are just going to pass that up to our view. So now we're going to go into our HTML. And we're pretty much going to be reworking what we have here. But we now are getting dynamically an array of content that we want to be able to swap in. And if I was to do this with jQuery, I'd have to do a lot of DOM manipulation in order to do this. But Angular will handle a lot of that stuff for us. So Rob, do you want to swap this out?
Yes, so you can see, like Michael just said, we do have statically list values here. But if I just take this code, and I'm just going to see, it's very similar to design here. The only difference being we're kind of pulling it using some Angular devices. Maybe, Mike, would you like to explain?
Yeah. So on line number 5, you'll see the star ng4. If you guys have written a for loop, you've probably seen something like this. For let movie of movies. So the movies is an array of movies that we have. So for every movie element, we're going to iterate through this. The async pipe is because that information is being requested asynchronously. When the content is updated and it's emitted to all of our subscribers, it's going to automatically handle the change of information for us. Everything that you see in brackets, like the href, that means that's going to be dynamically swapped out. Now, most elements have attributes. It's a key value pair, essentially. So the attribute href, which is a link, has a value, which is the URL that it's going to visit. Same thing for our image. The source, which is the source of the image asset, it's going to be dynamically swapped based on whatever the image of the movie is. And then finally, on lines 7 and 8, you see the double curly braces. Well, this isn't an attribute that we're going to be updating. This is just pure text content. So the double curlies is just for swapping out content. But you see, very simple template. Again, our HTML is 10 lines, but when Rob saves it and he goes back to Chrome,
Whoa.
we have all that content generated
Yes.
right there. And we were able to do that in roughly 12 minutes. But Rob, click on one of these movies.
Absolutely. Hey, Blade Runner, that looks pretty good. Look at that.
We swap to another website. We have our content here. This is actually the completed application. And if we go back, we can go back,
Yes.
Back to the Future. We have all of our movies here. Now, this was a quick application. We were able to put this out in roughly 10 minutes. Without the snippets, it probably would have taken us 15 minutes. I know a thing or two about how to write one line of code.
I don't.
Let's hit our slides back up, and let's hit what's coming up next. So we covered a lot of the things of where we've been, where we are, and how we got there. But there's other things coming up down the pipe. In fact, some of these exciting changes are happening right now. And one of the biggest ones, in my opinion, is progressive web applications. You may have heard that term before, but what this really looks to do is extend the use of the web across everywhere. Now, one experience that you guys might have is you open up Chrome on the airplane, you visit your favorite website because you're hoping maybe you'll be able to sneak onto the go-go in-flight, but then you don't want to pay $50, and then nothing is there, so you spend the rest of your flight playing the Chrome Dino game, right? Yeah, the dinosaur, you guys know what I'm talking about. That kind of sucks, right? Well, with progressive web apps are here to fix that, but there's a few requirements real quick. Let's hit them up real quick. The first one is progressive web apps need to be safe and secure. And this means content that we're delivering over has to be transmitted over HTTPS. We want a secure connection between the client and the user because web apps do things more than just provide content. They consume content from the user, whether that's your username or password, card information if you're buying something on eBay, or even your GPS information. If you're using an app to, I don't know, Uber Eats is actually available as a web app, you want to make sure someone else isn't getting all that information. So that SSL certificate provides a level of security. Another thing web apps have to do is be lightweight. Those mobile applications you install in your phone, an iOS application be up to 100 megabytes. We can make this in the web at less than 5 megabytes. Which one's going to be faster to load into your phone? The web app, probably. Progressive web apps also need to be flexible. We discussed responsive web design. It needs to look good everywhere. How many of you guys have downloaded an app that is only designed for my iPhone or only designed for my Android phone, but I want it on my iPad and it looks like trash, right? It's a pain to have to develop for multiple screen factors, but it's so easy on the web. So make it look good everywhere with just a little bit of CSS. Last thing that web apps need to do is they
need to be responsive.
That was supposed to be reliable.
They are very reliable as well.
We discussed, it sucks having to be stuck on an airplane and playing the Chrome dinosaur game, right? Web apps, progressive web apps, cache offline, meaning your assets, your routes, your videos. In fact, some of those HTTP requests that provide the information, those can all be cached offline. That way, when you want to do something, it actually works. I'm actually going to take over the computer real quick. I want to show you guys real quick what I mean. So, boom, 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 boom. All right. I'm going to hit up one of the websites that we showed. It is movies.ngpwa.com. I'm going to load this in. We get some great video content right here. If I click on it, I get information on it. I can go back, minions, all this content is here. And right now, I am connected to the internet. You can see I'm on the Wi-Fi, right? Take that Wi-Fi, turn Wi-Fi off. Give it a second so I'm disconnected. Click refresh. Page still loaded in. Click on the movie It information's already loaded in. In fact, it might have prefetched some of this content already. Not all of it, though. But I managed all this while I was offline. And I mentioned that these things need to look good on your phone. So this is what it will look like on a phone. Seems pretty like a natural phone experience to me. I clicked wrong movie. Shucks. Anyway, we want good experiences across the web.
Yes. Yes, and they absolutely need to be responsive, which I guess will be our last bullet point. But they're very sleek, they're very modern. You know, Mike said it before, but how many times have you downloaded an application only to find it to be either clunky on like an iPad, or it's clunky and not available on another device? These things are universally trying to work on everything, and they virtually work on just about everything. That's the true power of them. They're quick, they're very, very flexible, and they're also very responsive. Right. I guess that brings us to questions. Any questions? Yes.
How much would it take to have that prefetch everything then?
Not that difficult. What we are doing is we're fetching at request time. You can pre-cache that information. And once you make the request before you actually load that content in, it's going to be cached. We use a service worker in order to do that. And the service worker, we're also telling it to only store up to 20 HTTP requests. That includes things like the image assets, though. Any other questions? You guys might make it too easy.
All right. All right.
Wait.
Yes, question?
Did that application you were just demoing, did that run on the server-side software?
No.
Nope.
So it's all just like this.
It's a single-page web application.
Yep.
If you guys actually want to visit, that website is available. It's movies.ngpwa.com. And on the top right corner, you will see a GitHub icon. So like I said, we are definitely accepting pull requests. So if you want to contribute and make that a little bit better, we would greatly appreciate that.
Absolutely. There are a lot of frameworks for single-page applications and modern web apps. In this particular instance, we're using the newest version of Angular. So if you are interested in that, this is a great place to start and get some code.
All right, guys, thank you for being a patient and welcoming audience for us.
Excellent. Yeah, thank you very much.